Okay, welcome to everyone to another new video in our YouTube channel inside the Math Youth Academia, also called the MYE. So today we shall look one question on ladder problem, June 2015 paper 3, which says that a uniform ladder of length 7 meters rests against a vertical wall. It makes an angle of 45 degrees with the wall. The coefficient of friction between the ladder and the wall is 1/3 and between the ladder and the ground is half. A girl whose weight is half that of the ladder slowly ascends the ladder. Find how far up along the ladder will she climb before the ladder begins to slip. Okay, solution. Okay, normally it's advised that when solving a math mechanic question, it's advised to have our setup diagram for the clearly manipulation and understanding of the problem. Okay, realize that the question says that the wall and the ladder makes an angle of 45 degrees. The weight of the ladder is W and the weight of the girl is half the weight of the ladder. Okay, we have been asked to calculate how far the girl is climbing before the ladder begins to slip, and that distance I'll call it as x. Okay, we have the frictional force of the wall and the normal reaction force from the wall, the frictional force of the floor and the normal reaction force from the floor. Normally, in solving this problem, we need to find the respective frictional force and the normal reaction force for the moments to be solved, because when you want to solve moment, you need those respective values to find. So okay, we can recall that the frictional force is given as the coefficient of friction times the normal reaction force. Okay, the frictional force of the wall is given as the coefficient of friction between the wall and the ladder, which is 1/3 times the normal reaction force of the wall. The frictional force of the floor or the ground is given as the coefficient of friction between the ground and the ladder, which is half times the normal reaction force of the floor or the ground. Okay, conditions at equilibrium. We have the sum of forces to be equal to 0 and the sum of moments to be equal to 0. Those are two conditions we need to apply when solving ladder problems. Okay, applying the first condition at equilibrium where we sum all forces to be equal to 0. Vertically, we have Fw, which is the frictional force of the wall plus the normal reaction force of the floor, to be equal to half of the weight plus the weight. These two weight on the weight on 2, these two can cancel out to give us the weight. So I've just done it to simplify it directly without taking much time, because once the denominators are both the same, we just add the numerators. Okay, sorry. Okay, let us apply some techniques when okay considering a number line. Sorry. Okay, here I have positive values, positive, I have negative, and I have negative. Okay, the frictional force of the wall is vertically upward, which is also vertically upward, which is positive, correct? The normal reaction force of the floor pointing vertically upward, which is also positive. The vertical downward forces, both of them are pointing downward, which are negative. So I have minus W on 2 plus W, minus W on 2 minus W to be equal to 0. I will send the respective weights on the right hand side to be positives. I will now sum it to have 3W on 2, which is my equation 1. Okay, summing forces horizontally, I'll have the normal reaction force from the wall, which is pointing in the positive direction, which is RW, correct? I have my frictional force of the floor pointing in the negative direction, this direction here. I have the normal reaction force of the wall minus the frictional force of the floor to be equal to 0. I will send the frictional force of the floor in the right hand side to be equal to positive. Take note that the frictional force has been calculated here as the coefficient of friction between the floor and the ladder, which is half times its normal reaction force. I'll substitute here to have my equation 2. Okay, using equation 1 and 2 to find the normal reaction force of the wall and the normal reaction force of the floor, in which we have our equation 1 or equation 2. Okay, We cross multiply to find our normal reaction force of the floor to be 2 normal reaction force of the wall. Okay, the frictional force of the wall is calculated as such. The coefficient of friction between the ladder and the wall, which is 1/3 times its normal reaction force, in which I will substitute in this equation here, I will substitute here, plus the normal reaction force of the floor, which is 2 normal reaction force of the wall. I multiply by 3 and divide by 3. This can cancel out to, I will still remain with the same thing. So I'm just doing it to sum the numerators, since the denominators are both the same. I equate it to 3 times the weight on 2. Okay, if you simplify correctly, you have your normal reaction force of the wall as 9 the weight on 14. To find the normal reaction force of the floor, you just multiply by the normal reaction force of the wall, which is 9W on 14, to have 9W on 7. Okay, this is all about the first condition where we sum forces to be equal to 0. Okay, applying the second condition, which says we sum moments to be equal to 0. Okay. Moment is the force times the perpendicular distance, starting with the weight of the girl. Starting with the moment of the girl, sorry. Sorry for the line. Voilà, this is actually the force. And the distance from the pivot, which is perpendicular. This is my D that I'm checking here. I'm looking for a D, the perpendicular distance. Okay, using the Z identity, I'll have 45 degrees actually located here. I have 45 degrees. Okay, I have 45 degrees, and I need to find the perpendicular distance, which is actually D. So on this side now, I'll have sine 45 degrees to be equal to what? Opposite. Okay, this is D actually. Yes. It's what? Opposite, which is what? D on hypotenuse, which is X. I'll now cross multiply and I'll find D as, I'll cross multiply and I'll find D as X times sine 45 degrees, which is actually the perpendicular distance that we are looking for from the pivot times the force to give us the moment. So this distance here, this D we are looking for, is X sine 45 degrees. Okay, then now finding the moment, the moment now of the ladder. I have seen my perpendicular distance here. We're looking for the perpendicular distance from the pivot, D. This is also the D we are looking for. Applying the Z identity, you have 45 degrees. This is also our D we are looking for. So sine 45 degrees will be equals to opposite, which is D over hypotenuse. Our hypotenuse is what? Our hypotenuse is remember that the ladder is 7 meters. The ladder is 7 meters. That means that the weight is actually in the middle of the ladder. So we have 7 on 2 meters up and 7 on 2 meter down. So we have 7 on 2 meter up and 7 on 2 meter down. So that's it. You have 7 on 2 up and 7 on 2 down. So actually, then now yeah, so that we have now what the hypotenuse will be what 7 on 2 meters, in which I'll cross multiply to have the perpendicular distance. So have what the weight, which is the force, times the perpendicular distance, which is what 7 on 2 sine 45 degrees. Then now this is all about the anti-clockwise moment. I'll now equate it to the clockwise moments, in which the clockwise moments I'll have the clockwise moments I'll have the normal reaction force of the wall, in which should be a clockwise moment. We need now to use to also use the z identity. Okay, voila. So the perpendicular distance, this is actually the force. Perpendicular distance from the pivot will be actually located at this point here, D, in such a way that our 45 degrees will be actually this is our 45 degrees here up. You can also include our 45 degrees here if you wish. We are looking actually at this D here, at this D. So when you want to resolve it, this is our force. So we'll be having cos 45 degrees will be equals to what? Adjacent, which is our D, on hypotenuse. Our hypotenuse is actually 7 meters. Hypotenuse from the top of the ladder to the bottom of the ladder. From the bottom of the ladder to the top of the ladder is 7 meters. So I will have 7 meters. 7 meters in which I will cross multiply to have my perpendicular distance. So I'll have the force times the perpendicular distance will be 7 cos 45 degrees. Then now to find the perpendicular distance of the frictional force on the wall, we are still using the same principle. I have the force pointing upward here, and we need the perpendicular distance, in which this is actually our perpendicular distance here. So our perpendicular distance. So this is our D we are looking for here. It's our D we are looking for. So we will be having what? This is our D. So we are having sine 45 degrees will be equals to opposite all over our hypotenuse. Our opposite is D. Our hypotenuse is what? 7 meters. From the bottom to the top is 7 meters, in which I will cross multiply to have my perpendicular distance to be 7 sine 45 degrees. So my moment will be the force times the perpendicular distance to be 7 sine 45 degrees. This is all about taking the moments, because the trap here sometimes is to locate the perpendicular distance actually. Just taking much of your time, we just simplify and we can realize that the normal reaction force of the wall, as I said earlier, without us calculating the normal reaction force, we cannot find actually the moment. So the normal reaction force of the wall, we have it as 9W on 14. I just substituted here, times perpendicular distance, plus the normal reaction force of the wall, 9W on 14. I just substituted here. From then now the weight W will cancel out all over. Factorize W will cancel out, all out, and if we simplify correctly, or okay, W will cancel out, right? W will cancel out, and we shall remain with W will cancel out, and we shall remain with x on 2 sine 45 degrees plus 7 on 2 sine 45 to be equals to 9 on 14 times 7 cos 45 plus 1/3 times 9 on 14 times sine 7 times 7 sine 45 degrees. Okay, what will happen is just that we will factorize sine 45 degrees in the left hand side and factorize cos 45 degrees in such a way that we shall okay, let us just do it. Okay, we shall factorize. Okay, we have sine 45 degrees, okay, to be equals to x on 2 plus 7 on 2 to be equals to, on the right hand side, we factorize also cos 45 degrees. We factorize cos 45 degrees to have 9 on 2, because 7 divided by 14 is half, so you have 9 on 2 plus 9 on 6. Sorry for the writing. Okay, 9 on 6. Okay, I will now divide all through by cos 45 degrees divided by cos 45 degrees. Cos 45 degrees will cancel here, and sine 45 degrees on cos 5 degrees will give tan 45 degrees, in which tan 45 degrees is giving us 1. So tan 45 degrees is giving us 1, in which I will now be remaining with x on 2 plus 7 on 2 equals 9 on 2 plus 9 on 6, in which 9 on 2 plus 9 on 6, if you if you solve it well, you have 6, in which, since on the left hand side our denominators are the same, I will just add the numerators and multiply 6 by 2 to have 12. I will now have a linear equation. I'll send 7 on the right hand side to subtract 7 from 12, and I will be left with 5 meter. So our x is actually giving us 5 meters. So from there now, we will now see that or conclude that hence the distance covered by the girl before the ladder begins to slip is 5 meter. Okay, it's actually 5 meter. Okay, normally the diagram is not very well presented. Normally this is where actually the weight of the girl normally must be located here. Why? Because the distance from the weight to this top here, where I have my pivot, is 7 on 2 meters, which is 3.5 meters. So 3.5 meters now, that means 3.5 meters, right? So it's the distance from the weight to the pivot, in which the distance covered by the girl is 5 meters, which is more than. So it means normally the girl is located at this point here on the ladder, not on this not on this side here. So that's it. Okay. Okay, hence the distance covered by the girl before the ladder begins to slip is 5 meters. Okay, thank you very much for watching the video. Please don't forget to comment, subscribe and share.